Cequent Towing Products, electrical engineering. This video is primarily for you. We have a 2011 Dodge Charger. We were putting a wiring harness in. As you can tell, I've got the brake lights and the left turn signal on, and as you can tell, the turn signal and the brakes are shared by the vehicle's same LED bulbs. Even though this is a 3-wire system, the brakes and the turn signal share the same bulb. In the catalog, this is shown as being able to be hardwired if a T-connector is not available, which we opted to try the hardwiring route, and what we found is that this vehicle, the battery and the power distribution box are located in the back of the vehicle, so there's no need to run to the front. But what we have, the main harness that comes out of the power distribution box and supplies current up to the right side light, which is up there, and then the harness Y's off and splits over this way and runs off over to the left side wire. The brake light wire in the harnesses are different, and what I mean is the brake light wire going to the right side over here becomes disabled when the right turn signal is on. Otherwise, the lights would be, you wouldn't have turn signals. It wouldn't, the diodes on the LEDs would not blink on the car because the brake light wire would overpower that. I think you understand what I'm trying to say. So you can't hardwire a power module in here by simply attaching to the brake wire, because you're either going to have brakes and one turn signal, but as soon as you turn another turn signal on, you're going to lose your brake light on whichever side you made your attachment for the brake wire. In this case, we originally made our connection on the right side brake wire, and we had brakes and turn signals working okay separately, but when we'd have brakes with the right turn signal on, we would lose our left side brake light. So what I'm getting at is, the only way that this can be hardwired, you show that it can be hardwired in the catalog, is by the use of a diode. And what we've done here is we've taken a high power diode from a company called Roadmaster, which is what we use when we hook vehicles up to be able to be pulled behind motorhomes. And what I've done is I've taken a jumper wire from the right side brake wire over to an input, and then the left side brake wire has a jumper that comes over to the other input, and then the output of the diode goes to the brake power input wire for the power module. This will allow both of these separated brake wires to provide current to the power box without any type of feedback or crossover, bleed over into the other circuits. Once this is put into play, now everything is working correctly. We have left turn, right turn brakes, and regardless of which turn signal we have on, the remaining brake light stays lit. We did try to run just a jumper wire between the two pieces without using the diode, and all that accomplished to do was to make the brake lights on the car override the turn signals. So the brake lights were on all the time with no discernible turn signals when you had the turn signal on. So the only way that can be hardwired is to use a directional current limiting device such as a diode, and then that works. Now, I know that there's a T-connector available for this. We didn't have a T-connector available at time of installation, so that's the best fix in the field, and it should be just as good as the T-connector ever would be. But I wanted to make you aware of that, so that you could remove that from the catalogs, because even some professional wiring guys in the field aren't going to know about that, and that's giving them information in your lookup diagrams and in the catalogs that they can do a hardwire installation if need be, and they can't without doing some major modifications. So at any rate, there's some feedback from the field that I hope you can use again, and we thank you for all that you guys do. Appreciate it.